Welcome to this video on scatterplots and correlation. By the end of this video, you will be able to answer the following questions. What is a scatterplot? What type of data, categorical or quantitative, are displayed on scatterplots? What information can be obtained from a scatterplot? What is the difference between correlation and causation? Let's begin. What is a scatterplot? A scatterplot is a graph in which the numeric values of two quantitative variables are plotted along two axes. In a scatterplot, the pattern of the resulting points will reveal any correlation present. A scatterplot looks something like this. Roles for the variables. It is important to determine which of the two quantitative variables goes on the x-axis and which should be placed on the y-axis. This determination is made based on the roles played by the variables. When the roles are clear, the explanatory variable goes on the x-axis and the response variable goes on the y-axis. Remember, the x-axis is the horizontal axis where the explanatory variable goes, and the y-axis is the vertical axis where the response variable goes. Let's practice identifying explanatory and response variables. Example 1, hours of sleep the night before a test and the score on a test. Which of these two variables is the explanatory variable? Which of these two variables is the response variable? In your notes, sketch an x and y axis and label them accordingly. Pause this video, write your answer, and then unpause the video to check your work. If you said that hours of sleep is the explanatory variable and that the score on a test is the response variable, then you are correct. Good job. As the hours of sleep a person gets before a test increase, do you expect the person's test score to increase or decrease? Sketch your answer on the axis below by drawing a line with either a positive slope or a negative slope. Pause the video, write your answer down, and then unpause the video to see if you were correct. Being well rested usually helps people think more clearly and therefore may be expected to increase a person's score on a test. However, sleep is not the only factor in scoring high on a test, so the correlation between these two variables will not be perfect. What other factors affect a person's score on a test? Pause this video and list as many as you can. Then unpause the video to see if you are correct. Mastery of the subject matter is usually the strongest explanatory variable in a person's test score. Therefore, although there may be a positive correlation between hours of sleep and score on a test, the correlation might not be very strong since there are other explanatory variables that contribute to a person's score on a test. Example 2. Number of times per week a person brushes and flosses their teeth, and the number of cavities that they have in their teeth. Which of these two variables is the explanatory variable? Which of these two variables is the response variable? In your notes, sketch an x and y axis and label them accordingly. Pause the video as you do this, and then unpause the video to see if you were correct. If you said that the number of times a person brushes and flosses his or her teeth is the explanatory variable, and the number of cavities is the response variable, then you were correct. As the person brushes and flosses more regularly, would you expect the occurrence of cavities to increase or decrease? Sketch your answer on the axis below by either drawing a line with a positive slope, indicating a positive correlation, or a line with a negative slope, indicating a negative correlation. Pause this video, fill in your notes, and then unpause the video to see if you were correct. If you said that as a person brushes and flosses more regularly, the number of cavities that they have should decrease, then you are correct. However, regular dental hygiene is not the only factor in the number of cavities a person has, so the correlation between these two variables will not be perfect. What other factors affect how many cavities a person gets? Pause this video and list as many as you can. Diet and genetics also play a role in the number of cavities a person gets. Example 3, GPA and shoe size. Which of these two variables is the explanatory variable? Which of these two variables is the response variable? In your notes, sketch an x and y axis and label them accordingly. Pause this video as you do that, and then unpause the video to see if you were correct. Remember, in one of the beginning slides, we said that when the roles are clear, the explanatory variable goes on the x-axis and the response variable goes on the y-axis. Are the roles of our variables, GPA and shoe size, clear in this example? And they are not. We would not expect any relationship between GPA and shoe size. For example, I could have a high GPA and small feet. I could also have a high GPA and large feet. It's equally likely that I might have a low GPA and small feet. It's also equally likely that I would have a low GPA and large feet. So we don't anticipate a relationship between these two variables, so it doesn't matter which one we would put on the x or the y-axis, because again, we are not expecting any kind of correlation between these two variables. Correlation versus causation. We've been using the word correlation a lot in this video, so let's pause for a moment and actually define this term. Correlation establishes a relationship between two variables, but it stops short at saying whether or not one variable causes the other variable. Correlation does not suggest causation. For example, correlation would say there is a relationship between diet and exercise. It does not say that diet causes a person to exercise more or less, and it does not say that exercise causes a person to diet more or less. It only says that there is a relationship between the two variables. Causation actually establishes causality between two variables. For example, the medicine makes or causes your headache to go away. That is causation. Scatterplots. Please remember this. This is very important. Scatterplots only establish correlation. They only establish that there is a relationship between two variables. They do not state that either variable causes the other variable to happen. Let's use an example to drive home this idea that correlation is not the same as causation. The very first scatterplot I showed you was chocolate eaten versus Nobel Prizes won in a bunch of different countries. Would you expect there to be a positive, negative, or no correlation between these two variables? Pause this video, write down your thoughts, and then unpause the video to see whether you are right or not. It turns out that when we calculate the linear correlation coefficient, which is a topic for another video, the correlation between these two variables is quite high. Does this mean that eating chocolate causes more Nobel Prizes to be won? After all, the chocolate is on the x-axis, which means it's the explanatory variable, and the Nobel Prizes are the response variable on the y-axis. What do you think? Pause this video, write down your thoughts, and then unpause the video. In the case of chocolate consumption and Nobel Prizes, there are other lurking variables or confounding variables at work. This means that there are other variables that we can't see that aren't shown on the scatter plot that affect both variables, both the explanatory and response variables. What are these variables? Well, as the size of a country increases, you would imagine that the consumption of food in general, specifically chocolate, would increase. And also, as you have a larger population, the probability of anybody in your country winning a Nobel Prize would generally increase. The other thing that can affect both of these variables is whether or not the country is a developed or undeveloped country. Let's explore these ideas further. Population size. So as I said, chocolate consumption, as well as really any food consumption, is going to increase as the population of the country increases. A small country is probably going to either is going to consume less chocolate, and a larger country is going to consume more. Same thing with Nobel Prizes. If you have a large population, statistically speaking, you have more people who could potentially achieve Nobel Prizes. If you have a smaller country, you would have a smaller population to choose from. The other thing to think about is whether your country is developed or undeveloped. So developed countries are probably going to consume more chocolate because it is a processed and often imported food, whereas undeveloped countries may not have access to a luxury food. After all, you can go your whole life without ever eating chocolate. You can consume regular food and never have chocolate. It's a luxury, it is not a necessity. Likewise, developed countries can create and support more academics, which, if you think about it, higher education is really more of a luxury than a necessity. And in order to win a Nobel Prize, you really usually have to pursue higher level education. So hopefully you can see that these lurking variables, these confounding variables that are sort of off to the side that aren't actually represented in our scatter plot, really come into play when we look at these two variables. So the strong correlation coefficient between chocolate consumption and Nobel Prizes is a reminder to us that correlation does not imply causation. We know that chocolate consumption and Nobel Prizes have a high linear correlation coefficient. However, logic tells us that chocolate consumption, eating chocolate bars, doesn't make you more likely to win a Nobel Prize. And winning Nobel Prizes doesn't make you crave chocolate more or eat more chocolate. Moving forward in this chapter, be careful to remember that correlation, i.e., a relationship between two variables, does not mean that one variable causes the other to happen, even though we do use terms such as explanatory and response variables. Correlation does not imply causation.